Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. This is simpler using machine learning algorithms in R. And so we are now moving into our visualization. This is actually, I believe, Unit 4. And we're going to learn how to assess our model using the visualization, the Roc Curve, which stands for Receiver Operator Curve. It's a technique that is used for many algorithms, not all the algorithms that are available in machine learning, but can be very useful in terms of figuring out how well your model is doing. So having said that, let's go ahead and move over to our studio. So the first line, we're just going to run our packages like normal, and then we're going to load our dataset survey. We used the survey dataset in a previous model when we are trying to predict people's gender based on the size of their hand and other variables. And so because we're reusing that dataset, we have to do some of the same cleaning, where we remove many different variables, all here in lines 5 through 11, I believe, and we remove missing data. Now in lines 14 to 18, we set our seed. In lines 15 to 17, we make our train and test set, and then in line 18, we run our model. We've talked about this before, so I'm not going to explain it again. Just highlight, Control Enter, and run it. Now, this part right here, again, is review. We have to make our predictions. We put them inside our trained data set. And then we calculate how well we did in terms of predicting men and women. If the probability was greater than 0.5, we call it a male. All this has been done before. So I'm just going to run it, and then you'll see the results in a second. All right. So you can see here that it looks pretty good. The overall classification is 88%, very accurate. And then we repeat this process on the test set. So we set up our probabilities, predict, like so, 93.4%. Again, I hope I'm not going too fast. This is review. We have done this before. Now here comes the new stuff. We're going to slow things down. And so with the Roc curve, what it does is that it takes the true positive rate and the false positive rate to make a thing called a curve, which I'm going to show you in a second. And what it is, the power of this is that it allows you to be able to use a visual to determine the strengths and weaknesses of a model. Essentially, if the curve is good, if your model is really good, you're going to have like an L. So it'll go up like this and then over like an L. If it's not that good, it'll kind of be a diagonal line. This will make more sense when you see it. So we have to use a slightly different function for this, and the package for this is the ROCR. That's what it's called. And so we're going to make an object called pred.full. This is the best model, because what we're going to do here, let me make sure this is clear, is we're going to make 3 different models. One that is the best that we can make, one that is half okay, and one that's really, really bad. And how we'll make the different models is by removing different variables from the actual model that we created. It'll affect the type of curve that we get. So we're going to use the prediction function because the ROCR package has a different function for making the predictions. And then we're going to use the function called performance, and it's going to use the model we just made here, the object we just made here, and it's going to use TPR and FPR to make the ROCR curve. Okay, so, whoops, excuse me. We'll press that. And now we can plot it. I need to add one argument here so that you can see the line, and we just plot, and this is our curve right here. So you can see here, this looks really good. This is almost a complete L. And one reason this is almost a complete L, because if you recall, our accuracy was, 88%, 93%. And so this is why the curve is so almost that beautiful half T, if you will, in terms of what it looks like. Now, we're going to do the same thing, but this time we're going to make a bad model. So if you look in line 39, you can see right here that instead of using all the variables to try to predict the gender, what we did here is we used only the ones, only age and family. Now again, if you remember, age, that's not a very good predictor to tell us someone's a man or a woman, and their family status is not very useful either. This is why this is called a bad fit. And so we run this. All this right here should be familiar, lines 40 to 44 or so. You can see here that there's almost no classification for female. This is a really bad model. That's why, if you look closely here, we don't have the second row for female, because that's just how bad the model is. And so the overall accuracy is 63%. And so let's see here. We run this, and you can see here. See how we get this diagonal line? This is an indication of a really poor fit, a really bad model, because it's not doing a good job with the true positives or with the false positives. It's just random chance. You want it again to go right up and go straight over like that. This is a really poor model. Now, lines 50 to, let's see here, 50 to, let's see here, to 63 or so, we are doing a half bad model. So now we still have age and family in there. I'm sorry, that's not the name. Age and now hand. Oh, when I said family earlier, I was talking about making sure that it was I believe a logistic model, logistic regression. That's what we're using here. I should have explained that earlier. We're using logistic regression. Sorry about that. And so when we talk about family right here, we're talking about make sure that it's binomial. Excuse me, I made a mistake there. Now, moving to line 50, we're doing this all again, but this time we're using half bad. So we're using age plus the size of the hand. Remember, the size of the hand was an excellent predictor of the gender, but age is not that useful. And so we just run this. We do our prediction. We set our males and females like that. You can see how it's doing there. The overall accuracy is 83%. That's not bad. Not as good as 88. Okay. And then we do our test set. And you can see here that our test set is 80%. Again, not as good as 93. And so now in line 61 to 63, we do our ROC curve again. So we predict first. We do the performance, and then we plot it. And you can see here that it's almost a straight T. Notice, if you remember, and we're going to compare all three in a second, the very first one went all the way up and then over, but this one kind of stops a little bit earlier, and then it kind of goes over. That's what's happening there. Now, here's what we can do. In line 67 to 70, what we're going to do is we're going to put all of the different models that we just made on one plot so we can see them. So I plot the first, this is the bad model, this is the really good model, this is the okay model, and here's even a legend to allow you to see how it's doing. And so you can see right here that you can compare the different models, and you can see that that 5 there is a mistake in the code right there. That should not be there. But other than that, everything else is fine here. Now, if you want to put an actual number on it, the ROC curve goes up to an absolute value of 1, from 0 to 1. And so what we have here in line 72, 73 or so is we can actually look at the actual values for it. So let's see here. I do performance first. And now notice this time when I do performance, I don't do TPR and FPR. I do AUC because I want that value. And so here you can see for the bad model is 0.47. For the good model is 0.95, 0.96 basically. And then for the half bad model is 0.94. So they're almost the same. Half bad is not that bad. But again, so what's happening here is that not only do you have a visual that is available to you if you understand how to use these different functions from the ROCR package, you can also put a numerical value to them that can help you to assess again the quality of the model that you're making. Very, very powerful tool that is commonly used by many people when they're trying to develop models. So in this video, we covered a lot of information moving very fast, but about half of it was review. We set up our data. We've done this several times. We set up our training test set. We've done that before. We predicted on the training data. We've done that. We got the accuracy in the confusion matrix. All that is review. We did the same thing for the testing, for the test set. And then when we got to about line 34 is when we began to do something new with the ROC curve. That's what we're doing here. And so you use the prediction function to first get the predictions, and then you do the performance so that you can set up the actual ROCR plot, and then you plot it. The color is just for identification purposes, and the line width is so you can see it. I made it thicker. That's all that's about. So we did that for a good model. We did this again for a bad model. We did it for a half bad model, so you can compare them. And to make the good and the bad and the excellent model, all we did was remove or add different independent variables depending on how useful they were. And then lastly, we plotted them all together so that you can see them and make a comparison. And then you can also get the values for the AUC. That's the actual value, that area under the curve is what AUC stands for, and you can get those values. Now, something I forgot to mention was, Notice that little @ sign there. Because this is a slightly different object in R, it doesn't use the $sign to access things. Instead, it uses the @ sign, which if you use R extensively, you're probably already familiar with that. And so we got the AUC value for each one. It's that area under the curve. The more area under the curve, the better. That's how that works out. So I hope this video was useful for you and that you were able to understand the ideas that we're presenting here. My name is Derek Thomas. I am the Director of Educational Research Techniques. This is Simpler, using machine learning algorithms in R. Take care.